Hello, welcome back, guys. Uh, Now we will discuss a Floyd warshall algorithm. This algorithm used for single source. No, no, not single source sorted path. It is used for all pair sorted path algorithm. Right? So this is a problem that from GMC. The problem is to find the shortest distance between every pair of vertices in a given edge-weighted directed graph. So it's a directed graph, all right. So graph is represented as a adjacency matrix. So representation of graph is adjacency matrix. Let's say mat I J denote the weight of the edge from I to J, right? If matrix I J is equal to -1, it means there is no edge from I to J, all right? So here, if there is no edge, direct edge from I to J, so this is not infinity. It is given -1 here. Right? The cost of no edge, or we can, edge disjoint vertices is called not given infinity. It is given -1 here. So be careful implementing this and how to curve motion works and so on and so forth. So let's take this example here. Let's say this is a matrix of wait a minute. Let's say this is a matrix. Alright? This is a matrix given. So what this matrix is showing, we have a matrix 0 node, 1 node, and we have a node 2. 0 to 0 there is no node, and we have 0 to 1 we have cost of 1. 0 to 2 we have cost of 43 here, and from 1 to 0, so this is bidirectional here, and 1 to 1 always 0 here, and 1 to 2 is 6, 6, and 2 to 1 no edge, 2 to 0 no edge, 2 to 1 no edge, 2 to 2 is 0. This is a given graph, alright. So we have few things how to how we can make the shortest all pair sorted path, right? So there is a way to do this. Let's say we have 0 1 2 0 1 2, these are the vertices, and initial is 0 1 4 3, and 1 0 6 -1 -1. We first, let's say infinity, all right, then 0. So one one approach to do this all pair sorted path. So how can we do that? How to solve this? All right, there are a few things to consider here. Let's say I want to go from 1 to 2, 0 to 2, all right. I can go from 0 to 2 directly, all right. I can go through 1, all right. So cost of this 0 to 2 is 43 here, uh, 43, and 1 to 6 is 7 only. So this is sorting path. So this is not shortest path, this is the shortest path here, all right. This is the shortest path. Is there any setting to do the hmm? No, no. So this is the shortest path from 0 1 then 6, right? So we have few in the third parcel algorithm. We go, let's say this is a brute force approach only, all right. So let's say we want to go to 0, all right. So we want to go to 0. We can go to 0 directly. We can go to 0 by via 1. We can go to 0 via 2. We can go to 0 via 3 and so on. So we have only 3 vertices. So we can go to 0 via any vertex. Alright. Similarly, we want to go to 1. Alright. Let's see. We can go to 1 via 0. We can go to 1 via, or we can say, let's say there are many pairs, let's say 0 1, many pairs will 0 0, 0 1, 0 2. All right, and we have pair, uh, we have this pair 1 1, 1 2, like this. All right, 2 2, 2 0, 2 1. All right, 2 2. These are all pairs and etc. All right, so we can go from 2 to 2 via 0, via 1, via 2. All right, every pair have this 1 1. We can go 1 1 via 0, via 1, via 2, like this. All right, any pair can be. So all pairs, these are the all pairs, all right. So we have to find the all pair shortest path. So all pairs can be visited via any of the route, or we can say any of the node, all right. All the pairs. So we have few. So let's say we want to visit all the pairs. We want to all the pairs via 0, via 0. All right. Let's see. So we want to go to 0 to 0, 0 0. Let's say we have matrix 0 0. We want to go to via 0. So 0 0, 0 to 0 plus 0 to 0. So it's always 0, right? We want to go to 0 to 1, all right? So it goes like 0 0 plus 0 to 1. So this is for via 0 matrix, all right? This is via 0 matrix. So 0 to 0, then 0 to 1. So it is directly 0 to 1. Right? It is same one only. We want to go 0 to 2 via 0 only. 0 to 2 via 0. So it's at 0 0, then 0 2. It's only 43. This is unchanged here. Now what? All pairs I have visited via 0. Alright. 0 0 0 1 0 2. Now I want to visit 0 1 0. 1 0 via 0. So 1 0 via 0. So it goes like 1 0, then 0 0. So it is 1 0 only, which is a 1. All right. And similarly, then again, let's say all the pairs. So 1 pair is missing here, infinity. All right. So via 0 we are going 1 to 0, 1 to 1 always 0, 1 to 2 we want to visit 1 to 2 via 2. So via 0, all right. So 1 to 2 via 0, via 0. So 1 to 2 is 1 to 0 first plus 0 to 2, which is like, which is as 1 to 0 is 1 plus 0 to 2 is 43. It is 44. It is greater than 6 already, so we don't update it. And so we have to find this, all right, minimum of matrix I comma j and so on, right? Then 43. Now we have to go to 2 to 0, 2 to 0 via 0. So it is 2 0, this is infinity only. Then 2 to 1 via 0. This is also infinity because we cannot go, there is no edge to 2 to 0. And from 2 to 2 via, it is always 0. All right. So I comma I is always 0. All right. Matrix I comma I is always 0. And next thing, The next thing guys is here is like, let's say, so here what we will do. So one first time we visited all the pairs via zero. Then second time we will visit all the pairs we will visit all the pairs via one. Alright? One, two, three. Then we visit all the pairs via three. Alright? Then at the end we get the minimum vertex. Minimum all pairs shortest path. Alright? All the pairs with the shortest path we will get after this and so on. So this is how, so what we are doing, let's say we have a for loop for I is equal to 0, I less than n, I plus plus, then we have another for loop for accessing 2D array here, j is equal to 0, j is less than n, j plus plus. Alright, in this we have a, we want to update matrix, alright, matrix, this matrix only, matrix I comma j is equal to minimum of matrix, matrix not mat only, matrix I comma j comma matrix I comma via, we are going via, plus matrix via comma j. Isn't this true? This is true only. Alright, so which is minimum, then we update that if the minimum, and then we are going, first we go via 0 then via 1, so we need one more for loop here. So for via is equal to 0, via is less than n, via plus plus, then this, isn't it the simplest method? This is how we do that. All right, so come to the coding thing. Here we have a given matrix. All right, so right, we have a given matrix. It should be a square matrix, no? It will be a square matrix always. It's a square matrix. So how can we find the length? So so how can we in Java? How can, so let's say int n is equal to mat zeroth row dot is correct, or we have to use size. Is this a function or what? ENGT. Is this right approach? Is this correct? I don't think so. So let's ask AI how to find length of, we can say dimension of a 2D array in Java. This is giving answer. Right. So int rows is equal to my array dot length. It is my array here, length only. All right. My array dot length. The number of columns can be found by accessing the length property of the first row. Yeah, this is also right. I was doing right. Find the dimension of 2D array in Java, you need to determine the number of rows and the number of columns here. Rows is equal to length. Columns Right. I was doing right. Columns to find the columns. I need this only. Or this or also. No. This is also right. All right. Both the methods are correct. All right. What is it given? Board and notes. All right. Hmm. Length. Is this correct? I don't know. All right. I think this is correct. All right. So, what we are doing, first we have to go through the matrix, and where we find the minus 1, we have to change it to infinity. All right. And all the things, we have to change it to 0. Right. All the two, because there is no. So, for int I is equal to 0, I less than n, I plus plus, and for int what? Int j is equal to 0, j is less than n, a plus plus, and we have met row. Wait a minute. If met I comma j is equal to minus 1, what we have to do? Met I comma ij equal to, how to assign infinity to, right, how to assign infinite in a array element. What the hell? Right. Where is my favorite AI? ChatGPT. We lost ChatGPT. What is going on? Your file, you can assign value to constant. What the hell? No, no, no. This is not. This is not. Is this the double dot positive infinity? All right. Initialize an array element with a very large integer value in Java. What the hell, bro? What the hell? Which we can compare later with other value. All right, all right, all right. Integer dot max value. All right. So we can do this max value thing. Into integer dot max, what the hell, value, like integer dot max value. If we have, we are assigning this. So we are going to infinite. And one more thing after this, we have one more for loop. We can, what the hell, for I equal to, I equal to what? Into I equal to 0, less than I plus plus for into j is equal to 0, j is less than n, j plus plus, and met I, wait a minute, I comma I equal to 0. So we don't need this loop. We don't need this loop. Can we optimize this? No. We cannot. Alright, remember this thing and we have to do this again also. Alright. So what we are saying, so one more thing to notice here. This is giving modify the distance for every pair in place. So we don't have to consider the another matrix, which could be the cost matrix or we can say weight matrix. We don't have to consider. We have to update this matrix only. Alright. So going to what we are going to do here is, alright, for integer via ah via less than n via plus plus, right, for integer I is equal to 0, I is less than n, I plus, then we have for integer j is equal to 0, j is less than n, j plus plus, and then we have to initialize the list also. Alright, then what we are doing? Met I comma j is equal to math dot min. Is this correct? I am doing math dot min of aha min I comma j comma mat I comma via and plus matrix. We have to do this via comma j. We have updated and we have to in this we are doing this for matrix. We are going if there is an unreachable node, all right. Max value we have to assign the -1 thing here, all right. And do this also. This this is not thing. Alright, can we submit this now? Let's check. Alright. Yeah, we why the thing for wait a minute. Where is this? Right. We have done this. Is it right now? What? Yeah. All right. Thank you so much, guys.